Okay, in this video I will show you how to use the LabVIEW to implement and simulate combinational circuits. LabVIEW is a good tool for instrumentation and data acquisition. LabVIEW stands for Laboratory Virtual Instrument Electronic Workbench, and made by a US company named National Instrument. It is a good tool for instrumentation and data acquisition. It is a graphical programming language. Unlike the text-based languages where you have to write line of text to code your problem, here each function is represented by a graph. You pick a graph from a library, and this graph is a portion of your code. Then you pick as many graphs as you wish, connect them the way you like, then you run your code. This whole code is given an extension VI. It is, by the LabVIEW terminology, it is called virtual instrument, as if you are building virtually an instrument. This instrument could be composed of sub-blocks or sub-VIs, sub-virtual instruments. So you bring in as many VIs as you wish, you connect them to form the whole project. So it's an easy way to program your problem. It's a graphical language. You deal with graphs. If you need to multiply numbers, you pick a multiplier, you provide through a graph your numbers, you get the output, which is the multiplication of these numbers. So you don't have to code any or write any line of text. Okay, for example, here we're showing a combinational circuit, a well-known combinational circuit used in memory called decoders. So we are going to implement and simulate line decoders. All right. For example, this is a 2 to 4 line decoder. 2 to 4 line decoder. This is the block diagram of the decoder. This is the enabling line. These are the two inputs, I0, I1, and here are the four outputs, Y0 through Y3. And this is the truth table to show you the operation of this line decoder. If the enabling line is not active, which is 0, it's active high, regardless of the signals you place in I0 and I1, your four outputs will all be zeros. But if you enable your line decoder by placing 1 to your E, if you place 0, 0 to I0 and I1, you turn on your Y0, 0, 1, you turn on your Y1, and so on. The circuit to implement this 2 to 4 line decoder is shown here. So to build a 2 to 4 line decoder, you would need 1, 2, 3, 4 3 input AND gates, in addition to 2 inverters. And here comes the role of the LabVIEW package. So we're going now to use the LabVIEW package to implement and simulate this line decoder. Okay, first